Alright, today's lesson is on independent and dependent events. So we'll start with the independent events, which is what we've mostly been working with for the past week. We'll go ahead and define it and give a couple of examples. So an independent event is when one event does not affect the outcome of the other event. So some examples of this would maybe say you have a spinner, so you spin a spinner and maybe then roll a cube. So those two events don't affect each other because you have the result of spinning and then you have a separate result of rolling the number cube. Another example would be maybe to toss a coin twice. Bless you. Okay, because if you have a coin and you toss it, you get a result. And then you pick up the coin and you toss it again and you get another result, but the events don't affect each other. They were both separate events. Or if you had another sort of medium, like a dice. So maybe roll the dice twice. Okay, so now let's practice with two different independent events. And you'll need to make sure you pay attention to the difference between these two, because on your test you'll need to recognize when there is a dependent event and you have to work it just slightly differently. Alright, so we have a game and it uses a spinner and a number cube. Okay, so I'll make a little spinner and let's pretend that all of these sections are exactly equal and they all represent a different color. Okay, so on this game, they want to know what's the probability of not rolling a blue and then, not spinning a blue and then rolling a 3 or a 4. So we're going to find the probability of not blue and then 3 or a 4 on the number cube. Alright, so we'll have two separate events and we'll find the probability for each and then we'll combine them to see what the overall probability of the game is. Alright, so first, find the probability of each event. Okay, so the probability of not blue. Do y'all remember what to do? Look at your spinner. Remember, on our probability, we put the number of favorable outcomes on the top and the number of total outcomes on the bottom. So look at your spinner. The favorable outcome will be not getting blue. Well, how many chances are there to not get blue in our spinner? Jay?
4.
1, 2, 3, 4 is correct. Out of how many total choices on the spinner, Lamar?
5.
And there are 5 choices total. So we have a 4 out of 5 chance of not getting blue. All right, and then what's the probability of getting a 3 or a 4 on a number cube? So on a regular number cube, you get 1 through 6 on a regular number cube, one of each number, 1 through 6. So we want to put the favorable outcomes on the top, the total number on the bottom. So on the number cube, how many 3s are there? And how many 4s are there? So when you put those together, what do you get? So there's 2 favorable outcomes out of how many total outcomes on a number cube?
3.
Well, that's what you see, but remember, a number cube is a cube. So how many total faces?
6.
Out of total 6. Now, when we write our probability, we want to put it in simplest form. I noticed that both of these are even, so that tells me they're both divisible by?
2.
Good. So we divide by 2, and I will get 1 out of 3. Okay, so once again, our probability of not getting blue is a 4 out of 5 chance. The probability of getting a 3 or 4 is a 1 out of 3. Okay, so then the second part, because look, I'm not done. We have to find how to win the whole game. We've just found the separate events. Okay, so then find the probability of both events occurring. All right, and so to do that, we'll multiply. So we've got the first one, which was 4 out of 5, and the second one is 1 out of 3. So 4/5 times 1/3. So there's no crisscross reducing to do. So 4 times 1 is a 4. And 5 times 3 is 15. I double checked, still cannot reduce a 4 out of 15. And so that's my answer.
Do you have about 3 extra Chromebooks?
Okay, so on our next example, we have another game, but this time we've got 2 number cubes.
Independent or dependent?
Because you have to look back here on our examples on what types of events are independent. And you'll see some dependent examples in a minute, and you'll see the difference. Just give me a second. I'm almost there. All right, so in this game, it requires you to roll 2 number cubes. And our number cubes are labeled with 1 through 6. Okay, so what is the probability that will roll a 2 or a 4 on the first cube, and the probability of then rolling a 5 on the second cube? So to win the game, I have to roll 2 or 4 first time, and then I have to roll a 5 on the second time to win. Bless you. Okay, so on the first one, we're going to write down our probability. Remember, favorable outcomes on the top, total outcomes on the bottom. Well, on a number cube, what's our total outcomes?
6.
Okay. If I roll a 2 or a 4, how many favorable outcomes do we have? Okay, are we done with that one though? We should. Okay, so good. We'll divide them both by 2. All right, to give us a 1 out of 3 chance of rolling a 2 or 4. All right, then I have to find the probability of rolling a 5 on the second time. Okay, still, how many total outcomes are there for the number cube?
6.
Okay, probability of rolling a 5, favorable outcomes? How many 5s are there? 1. All right, so that's a 1 out of 6 of rolling the 5. Now we combine the two events. So 1/3 times 1/6. Okay, across the top, 1 times 1 is 1. Across the bottom, 3 times 6 is 18. So it's a 1 out of 18 chance of having both of those events successful. Catch you up later. All right, now let's look at dependent events. Well, the outcome can be affected by another one on the dependent. All right, so the outcome of one event can affect the outcome of another event. All right, so an example would be, all right, let's say you have a bag of marbles. You select one. Do not replace it. Then you select a second. So dependent events will happen when you have a group of something and I choose an item and then I keep it. Then somebody else can come along and choose an item, but they can't have the one I chose because it's already out of the group. So the probability numbers change because if we start with 10 items and I take one away, then the second person only has 9 to choose from. So the total number of outcomes will be different. Okay, so for example 3, the directions are a little lengthy, but we'll use the same directions for all of our examples, so we won't have to rewrite those. Okay, so we got a fruit basket, and people can choose from the fruit basket whichever piece they'd like. All right, so in the fruit basket there are 4 oranges, 7 bananas, and 5 apples. So this first guy, John, goes to select a piece of fruit at random. And then a second guy, Terrence, selects a piece of fruit at random. Okay, so let's find the probability that 2 apples are chosen. Okay, so we'll need to look at each event. First guy making a choice, then the second guy making a choice. So the probability that the first piece is an apple. Okay, well, look back up here in our list. We've got 4 oranges, 7 bananas, and 5 apples. So, how many favorable outcomes are there? Look up here. We want the first piece to be an apple. That would be favorable. Well, how many favorables are there? If the first piece is going to be an apple, there are 5 apples. So, we have 5 chances of getting an apple out of a total of how many? Yeah, we add 4, 7, and 5 and get 16. So there's a 5 out of 16 chance that John will select the apple. And that does not reduce. So then it's Terrence's turn. So then probability that the second piece of fruit is an apple. Okay, well, now it changes a little bit. Because John has an apple in his hand. He took it out of the basket. So now how many favorable outcomes are there for Terrence to also choose an apple? Lily?
We're at 16.
Thank you, Lily. All right, and now, how many total outcomes were there for Terrence, though? Don't forget, John took an apple away. Lily? So there's 15 pieces of fruit that Terrence had to choose from. So notice how our number of outcomes changed. The number of favorable outcomes and the total outcomes both changed. Okay, so then these are 2 separate events happening. So then to combine those and find the probability that 2 apples are chosen, the probability that we choose 2 apples from this situation, we take our 5 over 16 and we multiply it by 4 over 15. Okay, we can crisscross reduce here. 5 and 15 are both divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. I can do it again here. They're both divisible by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. So now I can multiply across the top. 1 times 1 is 1. 4 times 3 is 12. So I have a 1 out of 12 chance of drawing 2 apples from the fruit basket. So on this type of problem, when you have a dependent event, you must be very careful when you're selecting your second item. You must remember that because they were a dependent event, that one item was chosen to begin with, so that completely comes out of the selection. Okay, so for example 3, we're going to use the same situation. So we're not going to rewrite that. I meant example 4. Okay, so what's the probability that this time we get 2 bananas? Y'all try that. Alright, so for the first draw, how many favorable outcomes are there to get 2 bananas, or to get at least 1 banana? We have to try the first. 7. There's 7 in the fruit basket. How many total pieces of fruit?
16.
Good. Now, for the second draw, I want a favorable outcome. I need a banana on the second draw. Well, how many bananas are left?
6.
Out of how many?
15.
Good. Alright, here, these are both divisible by 2. 6 divided by 2 is 3, and 16 divided by 2 is 8. Alright, so now I can multiply across. 7 times 3 is 21. 8 times 15 is 120. I can actually divide both of these by 3. 21 divided by 3 is 7. 120 divided by 3 would give me 40. One more. Same situation. What's the probability that we get an orange, then an apple? Okay, so first let's see what's the probability of getting the orange. Say it again.
4 out of 16.
4 oranges out of 16 pieces of fruit. Okay, and then on the second draw, getting an apple.
5 out of 15.
All right, we have 5 apples still in the basket, but we only had 15 pieces of fruit left because we had drawn the orange out earlier. Bless you. All right, so 4 times 5 will give me a 20. 16 times 15 will give me 240. I can divide both of these by 20. And I can get a 1 out of 12 chance of drawing an orange, then an apple.